Okay, with this video I'll go on to Chapter 5, Section 5, and in this one we're working with exponents of base other than e and also with logarithms base other than e. Alright, and let's just refresh those formulas that we'll need for that. The derivative of some constant to the x power is going to be a to the x ln a. Now if you have a function of x in the numerator, in the exponent, then we would say that was a to the u, where u is a function of x. Then that is going to be a to the u times natural log of a, all the same, and then we're going to multiply by the derivative of whatever that function is in the exponent. For logarithms, then the log base a of x is 1 over x times the natural log of a, and when that's a function of x, or we would say log base a of u, where u is some function of x, then it would still be 1 over u times ln a times the derivative of u with respect to x, whatever that function for u was there. Alright, so let's get started with 4 to the x. Well, that's just 4 to the x times the natural log of 4. Now 4 can be written as 2 squared, and then you have natural log of 2 to the second. The exponent of 2 can be brought down, but that's fine, just the way that is there. Okay, next we have a base of 5 and we have an exponent of x minus 2. So this is the a to the u type, so it's just a to the u times the natural log of a, in this case is 5, natural log of 5, times the derivative of that exponent expression, which still turns out to be 1. And so we just have 5 to the x minus 2 times ln of 5, number 45. In this case, we're looking for the derivative of t squared times 2 to the t. And here you have a product, and you have a polynomial times an exponential. But it doesn't matter, we're just going to apply our properties of, we're going to apply the product rule. And so we have 1 d2, the derivative of 2 to the t is 2 to the t times the natural log of 2. Plus, so that's 1 d2 plus 2 d1. 2 is just 2 to the t, d1 is going to be 2t. And if you notice here, we do have a common factor of 2 to the t. We're going to multiply that by t squared ln 2 plus 2t. And I guess you could say we still have a common factor of t there even, so we could bring out another t, and we would get something like 2 to the t times the quantity t ln 2 plus 2, and the final version looks something like that. Alright, let's try to get number 47 in here. We have 2 to the negative theta, which is just like 2 to the negative x, times cosine of pi theta. So the two functions here are 2 to the negative theta and cosine of pi theta. So we're going to need a product rule, and within each of those factors we also have a function composition. So we're going to get two chain rules within a product rule. And instead of writing d dx, we're going to write d d theta there. So first of all, we have a product rule, so it's 1 d2. The derivative of cosine pi theta is negative sine pi theta times the derivative of pi theta, which is pi. So that's 1 d2 plus 2, which is cosine pi theta, times the derivative of the first function, which is 2 to the negative theta. So that's one of those a to the u. It's going to be a to the u times the natural log of a, which is natural log of 2 here, times the derivative of negative theta with respect to theta, which is just negative 1. And I believe when we simplify that out, we get negative 2 to the negative theta times pi sine pi theta minus 2 to the negative theta natural log of 2 cosine pi theta. We should factor out a negative 2 to the negative theta. And we end up with something like negative 2 to the negative theta times the quantity pi sine pi theta plus natural log of 2 cosine pi theta. And that should be it for that. Alright, so that brings us through number 47, and we'll pick up in the next video.